students, in the previous videos we discussed so many theorems. I discussed clear, and also I discussed how to find the A inverse and how to find the adjoint of a matrix. That all we discussed. So in today's class, just I'll recall the things, my students. So whatever I discussed in that, the more important results you should remember. So for that reason, I wrote here all the important results. I wrote here. Clear. So what we discussed, the first result I discussed was, my students, that is A into adjoint of, if A is any square matrix, then A into adjoint of A, or if you take adjoint of A into A, so if A into adjoint of A is equals to adjoint of A into A is equals to determinant of A into I. So if you take what is the result, my students? If A is any square matrix, then A into adjoint of A or adjoint of A into A, this value is equals to determinant of A into I, where I is the identity matrix. So this result I proved in the previous videos. And second, my students, if A and B are the square matrices, then determinant of AB is equals to, so determinant of AB can be written as determinant of A into determinant of B. Clear. And now, my students, if A and B are non-singular matrices of the same order, it means A and B are non-singular means what it indicates? The non-singular means if you take the determinant of A, then that should not be equals to 0. So if determinant of A is not equals to 0, then a square matrix A is said to be non-singular. So what here it is, the third result is, if A and B are the non-singular matrices, then, my students, if A and B are the non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. If you take the A and B are the two matrices which are not singular, if you take and if you product them, if you take the product of them, means that is also whatever result you are getting, that matrix is also not a single, that will won't be singular matrix, non-singular. So if you take AB and BA are also non-singular matrices. If you take the product, then that is also, that will be non-singular only. Clear. So this is the third result I discussed. And then, my students, that I discussed, if A is a square matrix of the order n, so if you have any one square matrix A of the order n, then if you wanted to find the determinant of adjoint of A, then determinant of adjoint of A is equals to determinant of A whole to the power n minus 1, where n is the order matrix, order here it is. Clear. So if you have the any one square matrix A of the order n, then determinant of adjoint of A is equals to determinant of A whole to the power n minus 1. Clear. So, my students, in that, but in particular I am taking, if a matrix is for a matrix of the order 2 cross 2 matrix, then determinant of adjoint of A is equals to determinant of A whole to the power, according to this, what is the formula? Determinant adjoint of, here it is, determinant of adjoint of A is equals to determinant of A whole to the power n minus 1. So instead of n, what I should take? 2. N value is here 2, because for a matrix of the order 2 here is. So that is 2 minus 1. So determinant of 2 minus 1 can be written as 2 minus 1 is 1. So that I can write it as a determinant of A. And now, my students, if a matrix is of the order 3 cross 3, then determinant of adjoint of A is equals to determinant of A whole to the power n minus 1. What is the n value here? Order of the matrix, that is 3. So therefore 3 minus 1. So therefore this value is determinant of A whole square, determinant of A square you can write, or determinant of A whole to the power 2. So if your matrix is of the order 3 cross 3, then determinant of adjoint of A is equals to determinant of A whole square. Clear. So these results are very, very important, my students, as well as in your competitive exams also. These results are useful. Based on this result, they will ask the questions. Clear. So all these results I discussed in the previous videos. Clear. And now, my students, the fifth one here it is, I wrote is, if A and B are square matrices of the same order. So if A and B are the square matrices of the same order, then adjoint of AB is equals to adjoint of B into adjoint of A. So adjoint of AB, if you take A and they are the square matrices, if you take the product of them and then after multiplying A and B, whatever matrix you are getting, to that if you found the adjoint, means that is equals to adjoint of, in particular if you take the adjoint of B and adjoint of A, if you multiply these two, that value is equals to adjoint of AB. This is the result you should remember. So up to here, up to 4 results already I discussed in the previous videos, but fifth I didn't discuss, but here I wrote here this because it is useful in your competitive exams. So in CET this may useful to us. So that therefore I didn't discuss it, but here just I gave the results here. Result I gave here is clear. So what is the second point here? It is adjoint of A inverse. So adjoint of A inverse can be written as adjoint of A whole to the whole inverse. If you take, so that value is equal to adjoint of A inverse. And the next here it is adjoint of A whole to the power n. This is equals to adjoint of A whole to the power n. Here adjoint of A to the power n I am taking. So this value is equals to adjoint of A whole to the power n. So this is the third result you should remember. And next my students, adjoint of K into A is equals to, so K is any real number, any constant you can take. So adjoint of K is equals to, take the K outside and K into adjoint of A. So adjoint of K is equals to K into adjoint of A. Clear? So these are all just briefly I wrote my students, but for these proofs, so that for that you should refer my previous video. In the previous videos I discussed all this in detail. I discussed there. So please try to watch my previous videos so that you can get the results for or proofs for this. Clear? And now my students, we will move to the questions. So one more questions, very important. Now whatever I am discussing here, questions, those are all of the weightage of the marks 1 mark. And those are very important. Definitely they'll ask one question from such type of question, such type whatever I am solving now. So based on that they'll ask for 1 mark in your annual examinations. Clear? So now we'll discuss the questions. Clear? So my students, here already I wrote the question. What is that? So if A is the square matrix of order 3 with determinant of A is equals to 5, then find determinant of, here it is determinant of adjoint of A. Clear? So what they asked? Find determinant of adjoint of A they asked. So what is the given data, my students? First we will discuss what is they given to you. So here it is given. So what is they given? Given the matrix A is a square matrix of order 3. So order means what it indicates, my students? N value they given to you. So a square if A is a square matrix of order 3, it means the matrix order they given means that is nothing but your n value. N is equals to 3 with determinant of A is equals to 5. Even they given to you determinant of A also. And what they asked? They asked that you should find determinant of adjoint of A. Clear? And we know that. We know the result. What is that? Determinant of adjoint of A whole to the power n. Determinant of adjoint of A is equals to, here it is determinant of A whole to the power n minus 1. So this is the and where here it is for nth order. So this is the formula for nth order. Clear? So I discussed determinant of adjoint of A is equals to determinant of A whole to the power n minus 1 for the nth order. Here I discussed. If A is a square matrix of order n, then determinant of adjoint of A is equals to determinant of A whole to the power n minus 1. So this is the formula I have. Clear? So this formula for the nth order. But what is the given question? Your order is n is equals to 3 here. So 3 means what is the formula? So therefore here it is for the order 3 determinant of adjoint of A is equals to, here it is. So this implies determinant of adjoint of A is equals to determinant of A whole square. Determinant of A whole square. And my students, already you know the determinant of A value. So therefore this implies determinant of adjoint of A is equals to, so determinant of A, what is the determinant of A? 5. So 5 whole square, and this is equals to 5 5 is 25. So therefore here determinant of adjoint of A is equals to 25. Like this you should calculate. So very important, in your annual examinations they will ask such type of questions. Clear? And even in the competitive exams also they may ask. Clear? For this what is required, just you should know this, you should remember this result means you can solve. Clear? So I hope you understood. Still if you have any doubts you can comment me, I will reply for that. And now my dear students, I will move to the next question. So I am going to write the second question. So the question is, here it is. Yes my dear students, the next question I wrote here. So this question was asked in March 2017 for 1 mark. Clear? So what is the question? If A is a square matrix of order 3 with determinant of A is equals to 8, then find determinant of A into A inverse. And as I told, this question was asked in Karnataka board annual examinations. They asked March 2017 for 1 mark. So very important question it is. So clear? So my students, so first they asked what they asked. They asked me to find a determinant of A into A inverse. Clear? And so this to find there it is determinant of A into inverse. We know that determinant of A into A inverse can be written as determinant of A into determinant of A inverse, because we know the result. Determinant of AB can be written as determinant of A into determinant of B, where A and B are the two square matrices of the same order. So likewise, A is the one matrix, A inverse is the matrix, another one matrix. Clear? So therefore we can apply this result. Clear? So determinant of A into determinant of A inverse. And this is equals to, what is determinant of A? Determinant of A already given to you. What is determinant of A? Determinant of A value is equals to 8. Clear? And we should find out the determinant of A inverse. For this, my dear students, we know that, or since if A is the any one matrix I have, if I interchange, if A is the any one matrix, if I interchange rows into column, that is nothing but if I for any matrix A, if I interchange rows into column, then that we can call it as the A transpose. So therefore we know that determinant of A is same as determinant of A transpose. This is the first property in the class, I think in properties of determinants. In that first property I discussed. What is that? For any matrix, if you interchange rows into column, then the value won't changes. That property is determinant of A is equals to determinant of A transpose. What is the property I discussed? For any matrix A, if we interchange rows into columns, then whatever you are interchanging rows into columns, if you find the determinant of that row value won't changes. Value remains as it is for any matrix A, as well as if you interchange the matrix, whatever matrix you have A, for that matrix if you interchange rows into columns, and then if you calculate the determinant, then the value is same as it is. So therefore determinant of A is equals to determinant of A transpose. This is A transpose. Clear? So therefore here it is, since determinant of A is equals to determinant of A transpose, so what is the determinant of this? Implies determinant of A is equals to 8. It means this is determinant of A transpose is also equals to 8. So therefore 8 into 8. So this is equals to 8 8 is 64. So therefore determinant of A into A inverse is equals to 64. This is your required result, the required answer. I hope you understood. So please, if you have any doubts, you can comment me, or else please watch my previous videos in the concept of properties of determinants. In the properties of determinants, the first property itself I discussed this one. Clear? So now we will move to the second question, my students. So now I write the third question we are moving. So what is that? That I am going to write here. So I erase this one. So please pause the video to note it down. Whatever questions or whatever remarks I wrote here it is. If you want those results means please pause the video. Then you can easily write down. Clear? So next I will move to the question. So this question was asked in I think as in March 2018. This question was asked. So what is that? I am writing here is the question. If is an invertible, if A is an invertible matrix of order 2, then find determinant of A inverse. And this question was asked March 2018. Clear? So my students, this question was very important because very tricky it is. Clear? So what should we find? We should find, here it is, A inverse. Clear? If A is an invertible matrix. So what is they given to you? If A is an invertible matrix, so it means here it is given A is an invertible. So A is an invertible means what it implies, my dear students? So A into A inverse is equals to I. Am I clear? So a matrix A is said to be invertible if there exists another one matrix B of the same order. Then if you take the product of this, then you will get the identity matrix. So that we can call it as the A. In that case, we can call it as the A is invertible. So therefore, they only given that A is invertible. A is invertible means that satisfies this condition. A and A inverse is equals to I. Am I clear? Yes. Then what they asked, matrix of order 2. Then find determinant of A inverse. To calculate determinant of A inverse, what I will do to this, my relations, I will take both sides determinants. So if I take determinants, so determinant of A into A inverse is equals to determinant of I. Both sides I took determinant. And this, my relations, just only we discussed this. This can be done as determinant of A into determinant of A inverse. And we know that determinant of I is equals to 1. So any identity, I means identity matrix. So for any identity matrix, if you take the determinant, that value is always equals to 1. Clear? So if you want means you can refer. So what is identity matrix? What we are discussing in this particular question, we are discussing a matrix of the order 2. It means I am taking the identity matrix of the order 2. So 0 1 0. This is the identity matrix of the order 2 cross 2. So here, if you take the determinant, please try to calculate this determinant. If you calculate the determinant means that is equals to 1. Clear? So 1 into 1 minus 0 into 0. 1 minus 0 is equals to 1. So therefore, determinant of I is equals to 1. So this can further we can write find A inverse. You are finding the A inverse. So therefore, keep here A inverse as it is. Determinant of A inverse is equals to 1. If this determinant of A, if you shift that side means that is goes to the denominator, that is determinant of A. So this is what your required result. So very important. So this result, therefore determinant of A inverse is equals to 1 divided by determinant of A. This is what they asked. Clear? So this question was asked in March 2018, as I told in your Karnataka board examinations. But many of students they didn't solve this because of some trick is there. What is the trick here? It is A inverse means we should take the determinant both sides. Usually, most of the students didn't solve this question. Clear? So because of that, they got 99 marks. Clear? So for that reason, please try to work out such type of questions also. Clear? We should use our mind so that we can calculate this one. Clear? I hope you understood. Still, if you have any doubts, you can comment me. Please try to solve more number of questions in your NCERT. Whatever questions you have, please try to all those questions so that you can write you can score more marks. Clear? And now, my listeners, next we will move to the next concept. Clear? So that we will discuss in the next video.